Hello everyone, it's Marcus from the S146 Box Boys, and today I'm going to be doing something a little different. We're not going to be uploading our normal podcast episode this week, but instead I'm going to be going over the 2004 AP Chemistry Free Response Question Form B, Question 1. This video will be more informational because a few of my classmates have already told me they would watch it and I like teaching. So this video is coming out because Mr. Cam said we're allowed to either make a video or make a podcast episode, and this week we weren't really able to secure any rooms for recording our podcast, so we just decided it'd be easier if I was able to make this video from home. But if you like our podcast better, the next episode should be coming out within the next 2 weeks, so stay tuned for that. All right, let's just jump straight into this question. And for question 1 on this FRQ, we know that it's going to be focused on chemical equilibrium. So for the reaction represented above, the value of the equilibrium constant Kp is 3.1 times 10 to the negative 4th at 700 Kelvin. So for part A, we need to write the expression for the equilibrium constant Kp for the reaction. So we know Kp is equal to the pressure of the products raised to the coefficient of that product, and then if there was let's say another product, that would be the second product over the pressure of the reactant. So A with the coefficient A up here, and then pressure of B. So for this equation, we only have one product, so we don't really need this for now, but it's just good to know for general use. So let's write down our equation actually. So N2 plus 3H2, and then equilibrium sign 2NH3. So for this one, A would be N2, so this is A. And there's supposed to be a 1 here, but you don't write out the 1 coefficient, so the little a is 1. Let's just write that for now. And then the little b is 3. And then H2 is our second reactant, so that's going to be this one. And NH3 is our product, so the little c here will be this coefficient, and then C, the large C, is what we're going to take from the pressure. So we just filled these in. So our equilibrium constant, or the expression for our equilibrium constant would be Kp equals P NH3, and then we square that because of this coefficient. We square that, and then we put it over the pressure of N2 times the pressure of H2 raised to the third power because of this coefficient. So this is our final answer for part A. So for part B, it asks us to assume the initial pressures are as follows. So the pressure of N2 is 0.411 atm, and the pressure of H2 is 0.903 atm, and the pressure of NH3 is 0.224 atm. So for part I of question B, we need to calculate the value of the reaction quotient Q at these initial conditions. So it's going to be QP is equal to, like the expression we just found above, it's going to be, except instead of Kp, it's going to be QP. So QP is equal to the pressure of NH3 squared over the pressure of N2 times the pressure of H2 raised to the third power. So we just plug in these values to where the pressure of NH3 is, and the pressure of N2, and the pressure of H2. So we get QP is equal to 0.224 squared divided by 0.411 times 0.903 cubed. And you can go plug this into your calculator, and you should get QP is equal to 0.166, Remember to use 3 sig figs because all of these numbers have 3 sig figs in them. So we're not done yet. We have to do the second part of question B, and that is asking us to predict the direction in which the reaction will proceed at 700 Kelvin, if the initial pressures are the ones that are given above. So we know that QP is equal to 0.166 at 700 Kelvin, and KP is equal to 3.1 times 10 to the negative fourth. So when you're comparing QP and KP, KP is when the reaction is at equilibrium. So since the reaction is not at equilibrium and these aren't the same value, that means this QP is not at equilibrium. So we know that QP is greater than KP. So this tells us that the number of products at QP is greater than the amount of products at KP. So there needs to be less products because it goes from reactants to products here. Products. So if there's more products here than there is at KP, we need to move some of these products over. So we know that because QP is greater than KP, I will just type this out. The reaction needs to shift to the left in order to reach equilibrium. So yeah, we know this because QP is greater than KP, so there's a greater amount of products and it needs to go back to its reactant form, because at equilibrium the reaction is always occurring and can go back and forth. So that's the question, or that's the answer to question B. QP is equal to 0.166 and the reaction needs to shift to the left in order to reach equilibrium. Okay, for part C, this one is not extremely difficult, but you have to know this equation. So the calculated value of the equilibrium constant Kc, given that the value of Kp for the reaction at 700 Kelvin is 3.1 times 10 to the negative fourth. So we need to know the equation Kp equals Kc times RT raised to the power of delta N. So we know this equation, or this equation shows the relationship between the equilibrium at pressure and the equilibrium in concentration. So we know that Kp is equal to 3.1 times 10 to the negative fourth, because it's given here, and R is the universal gas constant when it's liters times ATM over moles or mole K. So this is equal to 0.08206. You'll need to know this from ideal gas laws, and I'm pretty sure it is on the equations and constants table. And then T, temperature for this reaction, is 700 Kelvin, so we can do 700 dot. And then delta N, this is the tricky part. So delta N is the sum of the coefficients of the products minus the sum of the coefficients of the reactants. So in this case, we have, let's just put the 1 here, 1 N2 plus 3H2, and then equilibrium sign 2NH3. So we know that there's nothing to add here for the sum of the coefficient of the product, so it's just 2. And then the sum of the coefficient of the reactants, 1 and 3, so we get 4. So it's 2 minus 4. So delta N is equal to negative 2. So we know all these values now, and it's just like algebra, so we can solve for Kc. So it will be Kp is equal to Kc, Actually, sorry, I'll just rewrite this with the numbers in. So 3.1 times 10 to the negative fourth is equal to Kc times 0.08206 times 700 raised to the negative 2 power. So this should come out to something like this, I'm pretty sure, times, I think it is 3.03 times 10 to the negative, times 10 to the negative 4. Yeah. And then, because this answer is only 2 sig figs, you'll come out with an answer like 1.1 or 1.01. So Kc will be equal to 1.0. Because you get 2 sig figs from here, your answer has to be 2 sig figs. So this is the answer for part C of this question. Kc is equal to 1.0. Okay, so for part D, we need to find the value of Kp the value of Kp is, for the reaction represented below, is 8.3 times 10 to the negative third at 700 Kelvin. So we're given a new equation, and we need to calculate these new values of Kp at 700 Kelvin for each of these reactions represented below. So for the first one, this whole part D has to do with manipulating reactions. So we can notice that for part D, that this reaction is the same as this one, except it's just flipped. So NH4HS is the reactant, and NH3 and H2S is the product. So we're just going to rewrite this. NH3 plus H2S, equilibrium sign, is NH4HS. So we need to find the value of Kp for the inverse of this. So NH4HS, equilibrium sign, NH3 plus H2S. So this is our original value. So this is our Kp, and we know it is equal to 8.3 times 10 to the negative third. And we need to find the value of this Kp. So we're going to give it a dash because we're changing this equation. So we're going to give this dash, and when you flip a reaction, the Kp becomes Kp dash is equal to 1 over the original value of Kp. So this Kp dash is equal to 1 over 8.3 times 10 to the negative third. And this comes out to Kp equals 1.2 times 10 squared. So this is our answer for this equation. So for this equation, Kp is equal to 1.2 times 10 squared. So that one is pretty simple. And for the second one, it's a little more complicated. You have to do two things to this equation. So we can see that it's not the same as with just one step. We have to do two things. So first, we have to multiply this reaction by 2 for all of these coefficients, right? Because we look at this bottom one, we see 2 H2S and 2 NH4HS. So just looking at this, we already know we have to multiply this reaction by a factor of 2. So we're going to get our our original reaction. We're just going to rewrite it. So just for clarity. And we're just going to write 2's in front of everything. So we multiplied this entire reaction by 2. So we get 2 NH4HS. So when you change the reaction in this way, when you multiply it by anything, you're going to get Kp dash, because we're changing it again, right? So Kp dash is equal to Kp times the factor at which you multiplied it by. So in this case, since we multiplied it by everything by 2, it's going to be raised to the power of 2. So we know that this Kp is equal to 8.3 times 10, times 10 to the negative third. So Kp dash is equal to 8.3 times 10 to the negative third squared. So we find that Kp for this reaction is equal to 6.9 times 10 to the negative fifth. So we're not done yet. We only found Kp for this reaction here, but we need to find it for this reaction given here. So what we're going to do is we're going to take this reaction we found, and we're going to add it with the original equation given to us from the beginning, because we know that we need the N2 and 3H2, and we have that here, and we also have the Kp value, so it'll be, or that's how you figure it out. So we're going to have 2 NH3 plus 2 H2S, and then draw your equilibrium sign. It's equal to, 2 NH4. 2 NH4 HS. And then we're just going to rewrite this, the first reaction. So that'll be N2 plus 3 H2, which gives us 2 NH3. So we're just going to add these two reactions together so we can see that these two cancel out because they're both 2 NH3 on the opposite sides. So those are going to cancel out. And then we can just add the rest. So we get 2 H2S plus N2 plus 3 H2. And then that gives us 2 NH4 HS. So we can see that this reaction here is the same as the one that we need to find the value of Kp for. So we know that this reaction's Kp value is 6.9, Kp equals 6.9 times 10 to the negative fifth. And then this top value is 3.1 times 10 to the negative fourth. So in order to find the Kp value of this, we're going to put a dash here because we manipulated the expressions again. So to find the value of this, we need to do Kp dash equals Kp1 times Kp2. So let's just say this one is Kp1 and this one is Kp2, because this is the first reaction we used, and then this bottom one is the second one we used. So we're just going to plug it in. So Kp dash equals 6.9 times 10 to the negative fifth times 3.1 times 10 to the negative fourth. So 6.9 times 10 to the negative fifth, I'm just plugging this into my calculator, times 3.1 times 10 to the negative fourth. That will give us Kp is equal to 2.1 times 10 to the negative eighth. So the Kp for this reaction is 2.1 times 10 to the negative eighth. And that's it. We're done for this question. We found the value of this first reaction up here, and we found that it was 1.2 times 10 squared. And for this bottom reaction, we found it by manipulating this two parts of this equation. The first part, we multiplied the bottom equation by a factor of 2, and then we added the top equation, or the first equation, with the second one, and we found this Kp. So we found that the second one is 2.1 times 10 to the negative eighth. Okay, so thank you for watching this video where we finished question 1 for this FRQ, and the next part is question 2. So thank you once again for watching, and I hope this video helped anybody that needed any explanations, or if they didn't understand how to do any of these questions. This video was actually pretty fun to make, so let me know in the comments if you'd like to see more of videos like this. I know it's kind of nerdy, but I just like explaining stuff, so I had fun making this. So we'll be back to our regular podcast episode within the next 2 weeks though, so be on the lookout for that. And yeah, so thank you for watching.